Our speaker has joined the session, so we'll start soon. Yes, it's time to start the session. I welcome you all once again to the final day of the AICT Atal Academy sponsored 6-day online faculty development program on empowering healthcare with AI, advances, applications, and future directions. Today we have three speakers with us.
Recording in progress.
The first speaker is Dr. Ilangovan Chelaya. He's working in Micron and he's going to give a lecture on the topic AI for chronic disease management, innovative approaches and solutions. The second session will be handled by Dr. Shanmugasundaram Ravichandran, and he is going to present a topic on future trends in AI and healthcare, emerging technologies, and their potential impact. The third session will be handled by Rishika, and on the topic of telemedicine and AI, enhancing remote consultation and patient engagement. So these are the three sessions for today. Let me introduce you the speaker for the first session. It's my pleasure to introduce an accomplished technologist and an expert in failure analysis. Mr. Ilangovan Chennaya is currently working as YE Failure Analysis Engineer at Micron Technology, Taiwan. With 6 years of R&D experience, his expertise spans electronics product development, including academic research, industry collaborated projects, freelancing, on-site development, etc. He's efficient in C, C++, Java, and Python. Along with, he has hands-on experience in design and simulation tools such as Altium and SolidWorks. His specialization in microcontrollers like PIC, ARM, and STM, combined with deep understanding of communication protocols like UART, I2C, SPI, CAN, RS-232, makes him a versatile engineer. He has a strong grasp of analytics tools like MATLAB and Vue, enabling precise diagnostics and product development. Beyond his technical powers, he is well versed in agile methodologies, product management, and cross functional team collaboration, making a valuable asset in any team. His passion lies in designing for manufacturing and assembly, ensuring the products meet industry standards such as GIT, IEEE, and CE compliance. He is a skilled innovator in embedded systems, firmware software design, and hardware prototyping. He continues to push the boundaries of technology, Today, we have the privilege of learning from his vast experience and insights into the electronics R&D and failure analysis. A warm welcome to Mr. Ilangovan Chelaya. We are eagerly waiting to hear your session, sir. Kindly take over the session, sir.
Thank you. Thanks for the warm welcome. And let me share my screen. I hope you can see my screen.
Yes, sir.
Sure. Okay, first of all, good evening. It's afternoon there, right? Okay. Okay. Thanks for inviting me, and thanks for Dr. Shanmusundan for letting me know this session and inviting me here. And thanks for RIT and Honorable HOD. I see HODEC here, so I hope I can deliver some knowledge to whoever present here today, and let me use this time for giving you some different perspective apart from whatever presentations you heard before. Okay, so today let me keep the topic simple, but I would like to give you some international perspective on AI because I know because I've experienced a different country how they approach AI and how India approach AI and what we are lagging and what we want to develop. And let me give some perspective today. And thanks for your time and thanks for everybody joining today. Let's get into the session. Today I'm going to introduce what is AI and chronic disease and innovative approaches using AI. But I'll give you some different perspective. Okay, if you see AI initially used as chatbots. If you see the olden websites, the early websites, they used to incorporate for customer assistance and for answering FAQs. So that's the initial AI design for, and later they developed imaging systems and a lot of other things year by year, and now it's tremendous and it's booming around the world. So I think AI introduction is it's quite a bit general. So let me skip to the next topic. And if you see AI, we use for voice generation, chatbots, computer vision, like you even see the deep fakes and neural networks, generative AIs, which can generate you some images and some PPTs or like ChatGPT is a generative AI. So even kind of AIs exist. So my topic today is AI for chronic disease management and innovative approach for approaches and solutions. Uh, from here, I can introduce myself. This is Elango Chalea, and you can shortly call me as Ellen. And I work as a semiconductor engineer, specifically a failure analysis engineer in Micron Semiconductor. I work in Taiwan. I'm also an R&D specialist, and uh, thanks for inviting. Yeah. Okay. Before getting into the session, I would like to inform the audience to uh, even after the session, if you want to collaborate with me for any kind of innovation, or if you want to talk about any new topics, or if you want to learn new things from me, it's totally fine. I'm open to learn and open to teach. So open to share my knowledge. So it's good for us to keep in touch. Mm. Okay, I would like to give a short introduction of what is a chronic disease. Uh, Chronic disease is nothing but it's a long-lasting health condition like diabetes and heart disease and some of the skin disease. Even I have a chronic disease. It's called eczema. So it's a skin condition. It's followed genetically, and so that's how you get the disease, and it cannot be controlled. Even I cannot control my disease. It's just you can. I'm sorry, I cannot cure, but I can control. So if you know very well about the disease, it's very easy to control and keep you function normally. Um, Even diabetic is just a condition, so you can control it very well by strict diet and proper health monitoring systems. Okay, so let me take a case study of how a skin disease is detected, like a chronic disease, let's say eczema, for example. Uh, when you input an image, it just convert the image into pixels and compare the image to the reference image that is called datasets of different layers. Like it can be anything. Here they say pigment, lines, shapes, and symmetry. It can also be colors and other physical appearance, like yeah, exactly, shapes. And so from that comparison, what exactly match or closely match to the dataset, it just conclude this is your results. So if you feed a picture, if you want to categorize it, the model compare using the reference images that's called datasets. So this, I think, I feel everybody know. So uh, and this is an example image for detecting lupus. It's a skin disease actually. So it's a chronic disease. So mm, it is like a unusual pattern. Like this is how the disease look. Yeah, so if this number of dots or if this number of appearance compare with the data set, it's true. It conclude your disease is this. So that's how an AI work. Whatever human we see by our eyes and conclude by our intelligence, the same the same experience we load into a AI model, and it gives you the exact results. So have you heard of Google AI dermatology assistants? For example, some of us, even a lot of our old people and a lot of people surrounded by us, even have some kind of diseases, so skin diseases. Usually, we don't monitor. In India, we have this practice of not caring much in the initial stages. We make it worse after it get into some serious situation. Then only we consult doctors. So that's not a very good practice. But in other parts of the world, it's not the same. Today, I would like to give you some wider perspective of how foreign countries use AI and utilize AI, and how India utilize AI, and how India and other foreign countries see AI as a technology. So this is what for early detection. If you have a cell phone which is capable of detecting what is your skin condition, you can you can conclude I mean, you can know some initial results, and it can push you to consult a doctor. So that's what a AI system in mobile phones like this is very useful for uh, treating the chronic conditions. It can even say whether the condition is worse or is normal, or coming to chronic condition, it cannot be cured. So you should follow a proper diet. So it can consult some diet plans for you. It can even monitor the temperature around you. So it can conclude the temperature is not suitable for you, or the temperature is too high or low. So many things can be done using the AI. So I see my topic today is just a use case. Detecting the chronic condition or supporting the chronic conditions using AI is just a use case. I would like to give you more information how really AI works from the next layer of technology. Okay. Recently, from research, it's It said that cancer detection is really accurate using AI models. So I have a question for the audience. May I know what is the key components of AI? Like, let me say number one is data set. Number two, anyone?
Participants, you can put the answers in the chat box.
Yeah, sure. Okay, let me say one is data set. The other is the AI model, the whatever we are training. I mean the neural network. Any other key components? So coming to Indian perspective, coming to the technology, AI technology from Indian point of view, everybody say is the program or the data set or how efficiently we run the model or tuning the system or the neural network or custom program to calculate different data and giving you a yeah, yeah algorithm. Amazing. So anyone ever thought of hardware? Is the hardware important? So one of the key component of AI is the hardware. So today, as I mentioned before, uh, detecting the chronic disease or supporting the chronic disease using AI is one of the use case. But I would like to share more insights of how really it is done in the backend. Okay, today or 2 days back, there's a news. Have anyone heard of DeepSeek? Yeah, recently it made some impact in the AI market. Yeah, tensor processing units. Thank you. NLP. Good. Okay. So in this slide, why DeepSeek create an impact in NVIDIA? Any idea? So DeepSeek is a software company. They use AI, and yeah. But if you see why it affect NVIDIA, and they lost billions of dollars. Oh, sure. Yeah, right. Thank you. Okay. If you see NVIDIA support GPU uh, for AI systems, okay, for accelerated computing. For NVIDIA, we supply HBM, is a high bandwidth memory. I'm a person who test every day and touch every day the HBM. It's a very new technology to the world. I'm a person who directly handle the wafers. I directly test with my own hands every day. I handle a lot of HBMs and a lot of other DRAM and NAND technology. Coming to my job responsibility, I'm responsible for a completed wafer comes to me. There'll be some kind of defect or some cells not working. So I have to find the root cause why the section of DRAM or the cells of DRAM or any abnormality in the DRAM is coming into play. So I'm responsible to find the root cause using the layout analysis. I want to find the schematic. So uh, you have anything to say? Yeah. So I handle a lot of HPMs in a day. So uh, so why the DeepSeek is directly linked to some of the stock fall of Nvidia is they supply hardware to the AI environment. So that's why it's facing a huge trouble, and we are facing a huge trouble too as a memory company. So have you heard of this device, Rabbit? it's a failed device, but still, let's take into an analogy and let's do some analysis over this. Okay, let me. Okay, let's build a device. Okay, let's build a device like this to find a chronic disease like a skin disease or skin cancer or something. Uh, for that, we are going to build a device. Okay, so the key components of AI from an Indian point of view is the software, optimizing the software data sets and many other software related thinking. Okay, but coming to Taiwan, from my personal way of thinking, or if I want to, as a product developer, as a product development expert, if I think of implementing a solution or creating a product to the world, I think of the hardware first, where the AI run. Because for me, AI is just a software program. Is a way, I have a big question of where the hardware runs. So if you think of if you see the other countries' perspective, they are highly focused on the hardwares. Okay, give me some time. I'll answer this later. Okay, thanks for the question, man. Okay, for case study, let's dissect this product. Okay, so if you open this product, you can see a main microprocessor, and the next main thing is the memory, because you want to store uh, the data or the data sets into a huge memory, and you have to create a very fast memory so that it can grab the images and compare the images. So that's why a memory is very important uh, in a AI hardware. So if anyone interested in knowing the hardware, because I'm an engineer who developed the hardware, so if you have any question or interest, anybody, I'm open to discuss. Okay, so okay, coming to AI is just an application, and we are trying to optimize optimize the whatever happening around us in the world. We are trying to simplify the operations or automate the repeated operation using some intelligence. So that's what AI trying to do, and we are using vision, and we are trying to implement same techniques like our eyes and our hearing. So we are using multiple peripherals to understand the environment and to give the solution. I mean, the give solution is nothing but just the decision between A or B. If an object is placed in front of camera, I want to find what is the object. So that's what the core thing is happening, and we are using it for different applications like chronic disease detection and supporting systems for chronic diseases. Okay, so if you see this piece of technology, even inside, there are a lot of micro tech. Yeah, even I have some experience in using kind of motors. It's a little bit hard to commercialize. Yeah. Okay, this is one of the other product. Even it's a kind of failed product, but let's take this as a case study. So everyone from electronics, right? Electronic department, or anyone from computer science? Okay, I think everybody from electronics department. So from the electronic point of view, okay, CSE, got it. Okay, if you see the international technology approach, uh, let's take me in Taiwan. We always kind of see the product, the overall product. We really don't care what's inside it's running. It's kind of a use case or just a program or a piece of repeated program in a loop running inside the hardware. So we just want to know the threshold. Like, what is the maximum capability of the system? This camera going to detect in a rate of what millisecond? If you place an object in front of the camera, how fast it's going to detect the object, or so. That's what the key things we focus in Taiwan. So the software and the internal program is customizable, highly customizable, because we know the technique. I have some experience of customizing the libraries, and whatever libraries you use for example, let's say like Arduino. If you take Arduino, you have a OLED program, OLED program. You have programs for sensor. So I have experience in creating the programs. So the first thing I learned in Taiwan is how to create a library, you know. So I don't, if I take any sensor now in this stage of experience, I just don't look any kind of reference, or I don't look any, or I don't try to download any kind of libraries from internet, you know. I just look at the data sheet and program using the registers. So that's what we recently do in our recent works. So we create a highly customizable libraries. So from this, you can understand if you step out of India or step out of mm, a high resource country, uh, we try to create. You know, we try to create technology. We don't try to modify. Um, we don't try to download, or we don't try to take references. So we try to create technology. So that's it's a very good thing. I feel us everybody need to experience kind of creating technology. Yeah, we should not close ourselves within a circle of programs and creating algorithms or modifying algorithms. We should try to create our own algorithms and try to find the right hardware to run the algorithms and try to create as our own product and comply under the standards, and we can try to create as our own product. So I feel that's what the technology or the technology flow we are lacking in our part of in India. So I hope in near future we can create our own technology and our own hardwares too. Okay, I'll give you some deeper dive into this product. Even it has a projector. If you see this dot, the illumination, it's kind of a projector. It projects in your hand. So even further, they create their own MEM sensor. So it's just for your reference. Okay, this is the dissection of the product. If you see, it uses a bigger processor, or you can see Taiwan here. So Taiwan plays a crucial role in memory support for AI technology around the world, including NVIDIA, and we have TSMC here. So it's the largest. I think world will shut down without Taiwan. So it's a small country, but still it have a huge impact. So mm, okay, you can see a lot of like buildings and streets. So this is the mm, okay. I just want to explain here. Equal to the processor, there'll be a memory for AI technology. So this is what we want to know. It need a high speed memory. Okay, so coming to AI, whatever the for chronic support, or for speech detection or object detection or image detection or language model, for anything, a high speed processor and a high speed memory is very important. Mm, if you have anybody have interest over this systems, I can explain you later. So it's because I see some other department people, so I want to get into uh, some general modeling. Okay, so coming to this piece of hardware, if you want to create an AI system for any application, So it needs a lot of supporting hardware inside. So this is how we achieve a complete AI model. Because today in this session, I would like to differentiate not only the surface level of AI understanding. I would like to let you know, guys, what's really happening inside the model, or how a complete AI model function with A to Z, hardware to software and conceptualization, and an end product. Okay, so if you see, this many supporting systems are needed for an AI to function. So this many supporting system put together it's really important for efficient AI function. So we may think like an efficient AI model only rely on a program and other things, but actually not. It have other things too. If you see this piece of technology, uh, if an AI want to develop, we have to create a lot of supporting technology, which makes the AI complete. Okay, if you don't have a good interactive system, the AI cannot properly communicate. If you don't have a good microphone, if you don't have a good high speed camera, so it cannot function very well. So I don't know if you work with the Raspberry Pi camera recently, a new version of camera, it has a separate chip specifically for AI. So it don't capture and send the image data directly to the Raspberry Pi processor. Before that, it just save in the buffer memory and then later transfer to the uh, mm, Raspberry Pi processor. So it gives a very fast and stable processing. So because it just eliminate the one stage of processing before in the before stage within the camera. So that is called innovation. So uh, I just want to let people know, or let our guys know what's really the other technology development happening along with the AI. Coming to HPM in my company. Okay, let me go. Okay, this is one of my design actually. So you know how fast we build this piece of hardware is. Okay, here I have the. Let me show the image. Okay, this piece of hardware is built within a week. Yeah, starting from the conceptual design to choosing the components, uh, to programming, and A to Z product is developed within a week, and completely hand soldered. And this piece of technology, it have wireless, and it can also run a small piece of neural network. It can run a very small piece of automation. Okay, here I want to say even I built a hardware where an AI can function. Okay, so it can detect the temperature around and it can do some operations. So it's a small mini neural network. Yeah, so this piece of hardware is built by me. So if anyone interested to know more about how I do this, or I can say A to Z is done by me. So any question can be raised on mm, this kind of hardware related things. Okay, coming back to memory for AI. Okay, Micron, we develop HBM memory, high bandwidth memory. So if you see our designers, my or some of my friends in the design team, uh, they put a lot of effort in understanding what all things needed for AI, and how to make that. For example, object detection. Object detection. If you put something in front of camera, it have to detect what it is. So for that piece of technology, for that piece of program, there are a lot of things we have to consider from the hardware side. So a lot of things happen in the background for for the whole AI environment to function. So it's really fascinating to know about the background things. So I want to let you know today. It's not only AI, it's a lot of things happening around to support the AI technology. Okay, so okay, now let's come back to the AI model. Okay, so now if you want to detect the chronic disease, we have to build an AI model which run in the specific hardware built for it, or any basic hardware, or an existing hardware like our laptops or our mobile phones. So so innovative approach is nothing but how we find the repeated operations and and develop a AI model which can replicate the same.
Participants, please wait. I have some connection issues, it seems. He's connecting from Taiwan. Let me speak with him. He will be connecting soon. Please hold on.
Recording stopped.
Yes. Yes, sir, we can hear you. Sir, your screen is not visible, sir.
Recording in progress. Recording stopped.
Your screen is not visible.
Yes, sir. Yes, sir.
Yes, sir, you are audible, sir. You can share your screen.
Hello. Can you hear me? Hello. 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 Can you hear me?
Yes, sir, I can hear you.
Okay. Okay. I think we just have 5 minutes. Let me open my screen for any questions. So today, my overall, which I try to convey is, I want to introduce. There are a lot more things.
Recording in progress.
There are a lot more things happening to support the technology of AI, and starting from memory company to the microprocessor company to the hardware companies, and many other software companies from US and Netherlands. They are developing a lot of models, and they're trying to optimize the model. And yeah, sure. Yes, please. I see a hand rise. Can okay. So please go with your question. I see a hand rise. Okay then, yeah. So my overall motto, like when you think of AI next time, uh, you have to consider AI runs on hardware, and there are a lot more things happening to support the AI model from a hardware perspective, and from a AI model perspective, from a memory perspective. So it's a very broad subject, and in India we are focusing only on training the model and modifying the model, and we are trying to merge 2 or 3 models, or doing some modifications or new algorithms. So only algorithm-based things are going on in India. So or we try to implement our AI model in some of the existing hardware like Jetson Nano, or uh, a Raspberry Pi. So it's but it is also possible to do our own hardware. And so if you want to learn more technology, and if you want to understand more about the supporting hardwares for the AI development, so we can connect and learn together. And please feel free to connect to me anytime. Okay. Yeah, thank you. Any questions? So I think it's already time 5:30. I want to let to the other presenter. So if no questions, I think we can end the session. Uh, yes, doctor. Yes.
Sir, your first screen is visible in your PPT. The introduction to AI screen is,
Uh, please repeat again.
now it's changing.
Okay. Okay.
Participants, do you have any questions to discuss? If you have any questions, you can post it in the chat box, or you can unmute yourself and then you can ask the question.
So simply, this is my specialization. Yeah, this is what my job and this is what I do. Yeah. So if you want to know how AI run on this piece of hardware, yeah, we can have a good chat in future if possible. Yeah.
Okay, sir. Thank you.
Thank you so much.
Yeah, I don't think any more questions from the participants, so I conclude this session. Thank you so much, sir, for giving us a different insight about AI. So we were thinking, we didn't think about the hardware yet, but you have given us an idea of integrating the AI with hardware. Thank you so much for the nice introduction. And yeah, once again, thank you for giving this session, sir. Thank you. Participants, please wait for 2 minutes. The next speaker is about to join.